I can't tell you why. Well, hopefully you can. Today's title is Sides and Angles. And let's start off with a really simple one. This is like a little pictograph. Two quick theorems. If you have a triangle with two sides or two legs that are congruent, then you also have a triangle where the base angles are congruent. So we don't really name this one. We typically just write this one out like that whenever we need it. Yeah? And we have the converse of that. Remember the converse where you flip it around? So if the base angles are congruent, then the legs are congruent. So make sure these are both in your notes. I'm going to prove that first one to you, kind of informally. All right? So I've drawn a triangle here, and we'll call this triangle ABC. I've also drawn what we would call an auxiliary line down the middle. Now, the auxiliary line that I've drawn aux line is what I would call the median. So this point here that it goes to is the midpoint of that side. Now you probably can see now that those two triangles, that big triangle has been cut up to now, are congruent because all the corresponding sides are congruent. So by side, 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 those two triangles are congruent. Now we also have that rule that says, oh, if you've got two sides congruent, then guess what? Every part on that triangle is congruent. Therefore, angle B and C must be congruent. All right? So starting with just a simple concept, two sides congruent, we can work our way towards showing the base angles. All right. This allows us to summarize that if I want to prove two triangles are congruent, or sorry, that a triangle is isosceles, you can either find the angles are congruent or show the sides are congruent. And we would, by the way, mean the base angles here. So we just need two of them, right? And find two sides. This is just a good strategy. By the way, this is the definition of isosceles triangles. And then this is the theorem that we just quoted above. Yeah? If the base angles are congruent. Okay? All right. Now we've got an interesting kind of repercussion, a consequence of that which we just mentioned. And that is that we have the opposite sides and angles theorem. Okay? If two sides of a triangle are congruent, then the angles opposite the larger side will be larger than the angle on the opposite side. So that's a little hard to understand just in words. So I'm going to draw a little picture here. All right. Again, I'm going to be boring. Call it angle ABC. The side that is opposite angle A here looks like it's the largest side, and angle A looks like it's the largest angle. And this looks like it's the middle side. And notice it is opposite the middle angle. And then the smallest side, small, is opposite the smallest side. Now we can reverse all those and work off of the sides to the angles as well. So that's why I said over here, this works both ways. Yeah? If two sides are unequal, then the angle opposite the larger side will be larger than the angle on the opposite side of the other angle, of the other side, sorry. Should add that here. All right. Now we have a theorem that says if two angles are congruent, I'm drawing a blank now, I don't know what this one says. Oh, this is the converse of the one that we just did. So this one starts off with the angles, right? All right, so I'm not going to write this one out again because it's the same thing as the previous one, only arrows go the opposite way because you start with the angles, not the sides. Okay. Couple words we've used: equilateral, equiangular. When we're referring to triangles, it doesn't really matter which one we say is which. That is, if you say all the sides are equal, then all the angles must also be equal. So one of them implies the other one. Just that one refers to the sides, one refers to the angles. Now when we come to the world of quadrilaterals, that's going to be different, because this shape you can see is equiangular, but it is most definitely doesn't look equilateral. So just because the angles are the same doesn't mean the sides will have to be the same. All right. And finally, we come up to a triangle, and we know that AC is greater than AB. So this side is bigger than that side. Yeah? So this angle that's opposite it must be bigger than this side here, this angle. So when we write out what the restrictions are, then we say, oh, 6x plus 45 must be greater than 15 plus x. And then we do our little algebra. Guess that was a negative 45. 60. And so x is greater than 12. So x has to be greater than 12. In this case, could it be any number greater than 12? That is an interesting proposition. We know that both of these numbers here, both of these angles, must be less than 180, right? Individually. That is, this could be an obtuse, looks like an acute triangle, but any of those angles could be all the way up to 179, and then the other two angles, for example, could be half a degree each. So there are restrictions as well in the front end. So I'm going to write over here two possibilities. 6x minus 45 is less than 180. And I also know that 15 plus x is less than 180. So adding 45 to both sides, we get 225. Dividing, we get 3, 18, 45, 7 and a half. Here we have x is less than, looks like 165. So again, these are the two upper restrictions, and again I'm going to take the smaller of the two restrictions. X is less than 37 and a half. So combining these two things together, let me erase this over here. Okay, here's my two possibilities. X has to be greater than that and less than that. So x is, remember compound statements from algebra class, x is greater than 12 and x is less than 37 and a half. There's my final answer. All right. Good luck with your homework. Working with sides and angles